Okay, friends, so when you hear slope, what do you think? So here's the phrase, slope. Now I'm going to try to read your minds. You're my online student, so you're not here with me. But I've been teaching math for like 30 years, and I've heard people describe what they think of when they think of slope quite a bit. Some people say rise over run. And maybe this is what you thought of, which is totally awesome. Absolutely. That's like the verbal definition of the mathematical idea of slope. Some of you might even think of a more specific formula, something like y2 minus y1 over x2 minus x1. Maybe you thought of that, potentially. Maybe you thought of both. I'll number them. 1, 2. Maybe some of you remember the number, or the letter M. For some reason, the letter M has become associated with slope. Some of you might even remember an equation, y equals mx plus b. That's the slope component of it right there with the m, the y and the x and the b mean other stuff, and we'll get to that too. Maybe some of you remember a formula that looks like this, the change in y over the change in x, delta y over delta x. Maybe not. That's potentially something you thought of. Or maybe you thought of something else. I'm drawing a blank on other things you could call it. Gradient. I doubt you thought of that. It doesn't matter. Whatever you thought of is great. What slope actually is, these are the formulas of slope, except for that one. Well, that's the name of slope. That's slope used in another formula. These three things all say the same thing. We're going to see all this stuff today as we work through the lab. All of these things are measuring the idea of if you have data that suggests a line. If you have data that suggests a line, we're going to come back to what suggests a line means in the notes too. So let's suppose you have a line. This is a graph. It is the x-axis, y-axis. Same x and y that are in this equation. And you've got data that looks like it's moving through the axis kind of like that. The slope is the measure of how tilted that line is. So suppose that's a blue line and you've got a different set of data that kind of goes like this. You need a number to represent the fact that the pink line is more highly tilted than the blue line. Slope is the mathematical measure that is most commonly used to do that. You can have negative slopes. If a line, woo! Almost ate it on my own floor. If you have a line that drops, that slope needs to be negative. That slope needs to be positive. That slope needs to be positive and more positive than that one. And the idea of slope is these calculations in 1, 2, and 5, although we'll probably end up just using 1 and 2, can help us arrive at that measure. Let's read on and see how technology can help us.